Solar is on track to becoming the largest source of electricity by 2050. Yes! Woo! Yes! But how did we do this? How did we create the factories that make these incredible feats of science and engineering? Born out of urgency for the energy transition, huge factories the size of towns emerged, producing millions of solar panels at record low prices. This urgency, however, has led manufacturers to overlook other issues. It has pushed a new problem to the next generation: millions of tons of electronic waste. In our last video, we talked about the entire solar value chain. In this video, we want to zoom in to the third step, manufacturing. And to make this step circular, we asked ourselves, how can any solar panel factory around the world be retrofitted to produce circular solar panels? I'm thrilled to share how we're already retrofitting a factory in the Netherlands in this way. I'll pass it on to my engineering colleague Zola, who's going to show you the ins and outs.
First, we need to understand how solar panels are normally being manufactured. That's why we are here, at this factory of our manufacturing partner, Kameleon Solar. Here we're going to show you how solar panels are being produced and what we do differently. It starts with soldering the cells into so-called strings. This machine, called the stringer, places the cells and their connectors into the right position. It checks for defective cells and removes them if necessary, and then it solders all the cells together into one large string. These cell strings are placed onto the front glass with a robot arm. The cell strings are then manually soldered together to create the electrical circuit. An EVA sheet and a backsheet are stacked on top of the cells. This conventional module is then placed in a laminator for about 20 minutes to melt everything together under high pressure and heat. When the module comes out of the laminator, the EVA layer has melted, and the solar cells, glass and backsheet are all glued together.
And here's our opportunity. Laminating a solar panel is an energy and time-intensive process, which makes it one of the most costly steps in the manufacturing. And after gluing the solar panel together, it's impossible to take apart effectively. To make modules circular, we need to adapt this crucial step in the production process. Zola is now going to show you how we are adjusting this step for Kameleon Solar.
Biosphere eliminates this production step and the glue layer. Instead, we place small dots in between the cells. This keeps the glass and the cells in place while avoiding the cells being sealed in layers of glue, resulting in the cells being intact and reusable. Here you see the machine that I've designed and built together with our team these past few months. The 5 syringes dispense glue onto the front glass, which is cured by UV lights, creating the dot pattern in minutes. Next, the cell strings are placed in between the glue dots. An edge seal of butyl rubber is placed around the edges to create a water and airtight seal. The back glass is placed precisely on top. Our module is placed into the laminator with 2 main differences. First, we use low heat and low pressure. And secondly, it only goes in the laminator for 7 minutes instead of 20. This ensures a proper sealing without excessive energy use, In the future, we will also add our liquid filling process, which is currently under development, into the production line. The main advantage is that our sealant uses low temperature and low pressure, which means that re-module is not only fully disassemblable, it also reduces the production cost and energy use significantly, while maintaining the integrity of the solar cells. I'd like to stress it again. What you're seeing here right now is the first ever circular solar production line.
Hi everyone, my name is Büşra Yılmaz de Pont. I'm the CTO of Kameleon Solar. We are a BIPV manufacturer from the Netherlands. BIPV is an abbreviation for Building-Integrated Photovoltaics, where PV elements replaces building elements and takes its functionality as well as just produces electricity, which you will never have with the regular building element. The PV market is relatively really fresh, and we still have like the old PV system still functioning somewhere, but so far we have never considered what happens when the PV module is in the end of their life cycle. How can we recycle them? What is the effect environmentally from the circularity perspective? Our line, like any other line, is very standard production line. And adding Biosphere Solar's concept to that was a big challenge because we had to come up with new ways of laminating. Because there's no encapsulants, you cannot really laminate the way you normally would do. So we went back and forth with them and we worked together, which was really fun because the team is very dynamic and young and is really passionate about what they do, and what I really believe what they're doing is also going to change the way we look at PV modules, in the future. So now we're in the step where we actually laminate and make the modules and finish them up in their own way, which made us also learn new ways of laminating and new ways of making modules and new ways of looking at modules in general. In the end, the concept that we come up with together can just be applied to any production facility, I think, and then it's going to be a very good learning case for everybody who's interested in making circular modules, and Biosphere Solar is really in a head start with that.
Did you enjoy this video? As a solar technology lab that is ready to bring this innovative and cost-effective solution to the world, we are looking for partnerships all across the value chain. Feel free to reach out to us for projects or funding opportunities that introduce the solar industry to the circular economy. You can reach out through our websites, find us on LinkedIn, WeChat, or send us an email. Thank you for watching.